Now, another piece of evidence is the anatomy of related critters and their developmental processes. We're going to see this when we look at animals. Animals have developmental processes that are in common, that they share with all other animals and no other critters. But a really good example of this anatomy of development is in the bones of limbs, in limb bones. And you can see all of these different vertebrates. These are all, it looks like, yeah, they're all vertebrates, and 3 of them are mammals. We have 3 mammals here and 1 bird. But if you look at the pattern of bones, we have a big long bone. Even the whale has a big long bone. This is like your humerus, this arm. And then you have 2 long bones in like the forearm, the ulna and the radius. And humans have an ulna and radius. Dogs have an ulna and radius. Whales have an ulna and a radius. They just are smaller and they're adapted to flipperness. And look, the bird has an ulna and a radius. And then you have a bunch of blobby bones. Look at this, these little yellow blobby bones that all of them have. What? Yellow blobby bones and then fingers. Look, even inside a whale fin. How cool is this? You can imagine, oh, I just drew a fin of the whale. A whale has fingers inside of its fins. Fish do not have fingers inside of its fins. Fish do not have this pattern that is found in critters with 4 legs. And you might be like, dude, birds don't have 4 legs, but their wings are their front limbs. They just have been slightly modified to do a thing. These characteristics are homologous characteristics. Did I spell that right? Character, it is with a CH. Homologous characteristics, I don't know, how do I say this? Demonstrate, display, shared ancestry. Display is the wrong word for this. They provide evidence of shared ancestry. If you have long bone, 2 bones, blobby bones, fingers, if you have that pattern, then you are more closely related to other critters that have that pattern. And those homologous characteristics actually do show shared ancestry. Now, I'm going to talk about something a little bit different. There's, in contrast to homologous characteristics, we have analogous characteristics. And those are similar, but evolved separately. We've got wings up here. We've got bird wings and bat wings, and you can see the underlying bones. The underlying bones are homologous. Like the ancestor of bats and birds had that bony structure, which is how you know that that is a homologous trait. However, the wing part, the fact that they fly, maybe flight is the good characteristic. Flight is analogous because the most recent common ancestor between a bat and a bird, I know we're going to talk about this in more details, but birds are basically reptiles. They're avian reptiles. So they are quadrupeds. They have our, not quadrupeds, tetrapods. They have the pattern, and that is homologous. But the fact that they're flying, that common ancestor was not a flyer. They evolved flight separately on their own paths. Oh, look, and this is exactly what this is showing you. That we have the limbs That's a homologous trait. However, evolving into wings is analogous because the ancestor did not have that trait. It evolved twice. Does that make sense, the difference between those two concepts, homologous and analogous? Our anatomy, the evidence found in anatomy and development supporting evolution is just crazy talk wild. What causes structure? What underlies the structures that we see? Home kids, genetics. That's next.